Hello and welcome to Technology Update. Living in our computerized world, everything is driven by the push to be both smaller and faster at the same time. Nowhere is this more evident than with the creme de la creme, or supercomputers if you like. The world's fastest from just a decade ago wouldn't even crack the top 500 today. Supercomputers are actually a part of our everyday lives, even if we aren't aware of it. For example, at places like Russia's main meteorological center, these powerful machines are put to the test every day to crunch unthinkable amounts of data in order to give us a better glimpse of what weather awaits us. They can be used for planning flights more efficiently and for getting a jump on potentially dangerous storms before they're obvious in the skies above. The performance of such complex calculators is measured in flops, or floating operations per second. The most recent addition to Roshydromet's arsenal here is capable of up to 35 teraflops, or 35 trillion calculations per second. With the number of data points constantly on the rise, researchers are in constant need of more processing punch.
Every 2 years, new systems appear that have the same form factor. That is, they take up the same amount of space, and most importantly, they use the same amount of energy, but have 20 to 30 times more processing power than previous generations.
Computers as we know them got their start in 1941 with Konrad Zus's Z3. That was followed by the ABC computer, which employed vacuum tubes to implement the switches. However, computers didn't become super until 1965 with the CDC 6600. It's a slippery definition, but its ability to perform tasks 10 times faster than anything before it led many to label it the first supercomputer. At the same time, Soviet engineers put the finishing touches on the BESM-6. Armed with a 48-bit processor and 10 MHz clock speed, it turned out 1 megaflops per second. In 1974, Seymour Cray came out with the first computer bearing his name, and since then has been considered the father of supercomputing in the West. On the other side of the Iron Curtain, Boris Babayan had attained the same status with his team's 10-processor Elbrus II. And fast forward to today, and only a few dozen countries are capable of producing computers of truly superpower. The US has been and probably will continue to be the top dog here, accounting for around half the names in the most recent rankings. However, following a tough time in the 1990s, Russia has made a major resurgence over the past decade. Although it hasn't been a straight shot to the top, the direction is clear: more machines in the top 500 and more power packed inside. And recently, one Russian machine broke the top 20. Since 2009, Moscow State University has been the proud possessor of Eastern Europe's most powerful computer. Designed and put together by a Russian company called T-Platforms, the Lomonosov supercomputer made its splash on the world computing stage by clocking in as the 12th fastest setup on the globe. Since it was installed, the fast-paced processor has had several upgrades and remains the top machine in the country. In the most recent list, Lomonosov hit a peak of 1.7 petaflops, or 1.7 quadrillion calculations a second. But all that processing power doesn't come easy. Fueling the lightning-fast tabulations are some 2.8 megawatts of electricity, which is enough to power several thousand homes. A large chunk of that is eaten up by the massive cooling system you see here. Because of that, it's reported the supercomputer almost never runs at full power. As a result, Moscow State University's Lomonosov plummets in the world's standings when you take energy efficiency into consideration. The so-called green list rates the top 500 according to how many calculations they squeeze out of each unit of energy. Offering 322 megaflops of processing might per watt, the Lomonosov falls all the way to 186 in the green list. There are several ways to keep supercomputers as heat under wraps. Air ventilation may seem like the simplest setup, but it offers the worst results in terms of heat exchange. Much denser liquids, then, have been looked to as a better way to wash the heat away. These have ranged from relatively rudimentary tubes strung along the processors to a new IBM system that pumps warm water around CPU hotspots. However, perhaps the most radical attempt to harness the cooling qualities of liquids was the Cray II, which used a waterfall system that pumped an inert refrigerant directly onto its servers. Now, that idea failed to gain traction immediately, but out here amongst the slowly melting snow in Russia, the notion of a fully immersed cooling system may be coming out of hibernation. For that, however, they'll need to rely on more than just the country's northern climate. Here in Pereslavl-Zalesky, there's a team of researchers working to make sure that the globe's most powerful processors don't get too hot to handle. Located a few hours to the northeast of Moscow, much of that work is going on here, at the Ilomaizian Program Systems Institute. Compared to many of the country's other storied universities, it may seem like a newcomer, having been founded in 1984. But since that time, though, it's established a reputation as one of the centers of high-power computer tech. These eggheads have their fingers in all sorts of pies. For example, they're equipped to print their own circuit boards and have even dabbled in cluster computing solutions. But most interesting for our purposes is their work in the field of supercomputers. They're the head organization in an international partnership developing bigger and better processing machines. Under the name SCIF, Program Systems Institute works with around 24 other institutes and research centers in Russia and Belarus. Over the past decade, that partnership has resulted in increasingly sophisticated generations of supercomputers, including at least 5 making it into the top 500 biannual rankings. But as technological capabilities have progressed, old concerns have become more serious and require new solutions.
If you reduce any electronic device in size, it means that all the heat produced by it will no longer dissipate in a large area, but will instead be constrained to a very limited space. As a result, you have a huge amount of heat in a very small area. While previously a server rack used to give off 20 kilowatts of energy, today that figure is up as high as 100 kilowatts. That's a colossal amount of heat. It's simply impossible to deal with that much heat using traditional cooling methods, using air ventilated systems.
With that in mind, they've turned to the seemingly extreme solution of fully submerged cooling. Together with a company called Storus, they've engineered an entire system that maximizes the advantage of liquid-based cooling. Now, some of you might be thinking, hang on, wires, electronic circuits, submerged in water? But don't worry, this coolant is specially designed not to interact with server boards. It doesn't conduct electricity. It's an inert dielectric chemical composition that's both non-toxic and hypoallergenic. Now, the exact recipe for this cooling concoction remains a tightly guarded secret, but they feel the chilling capabilities of their immersed system speak for themselves.
A typical air-cooled server requires about as much energy for the cooling system as it does for carrying out calculations, which means energy demands are increased by 100%. But our system only requires as little as 5 to 7% additional energy. In other words, it is some 15 or 20 times more energy efficient than traditional air cooling systems.
According to those involved, this was a true partnership between Storus on the business side and Program Systems Institute in terms of engineering. And in their minds, this kind of cooperation is ideal. Business-focused people often have an idea for a finished product in the real world, but lack the technical know-how to get it to that point. Academics, on the other hand, are great at finding solutions to complex problems, but not always at envisioning how that'll find its place in the market. After 2 years of work, the teams have an experimental model that shows just what's possible when you take a plunge with their immersed system. Given how hot of a topic supercomputer cooling is in the business, there's some competition to be the liquid-cooled champs of Russia. For example, those at the Joint Supercomputer Center at the Russian Academy of Sciences have turned to a more restrained, but no less technological use of free-flowing fluids. Founded in 1996, the center has been and continues to host a number of super powerful processing machines. The center was originally built with much different, much larger supercomputers in mind. However, thanks to seemingly never-ending technological innovations in this field, the sheer size of these great calculators has massively reduced while the processing power has expanded exponentially. The latest example of this trend is RSC Group's MVS-10P, installed last autumn, just in time for the most recent rankings. It boasts the very latest Intel processors and co-processors. With 2 of each on each node, the MVS-10P installed here cranks out more than 500 teraflops at peak capacity. Using a miserly 181 kilowatts in total, it came in as the 30th most energy-efficient supercomputer in the world, squeezing out nearly 2,000 megaflops per watt.
One reason why the liquid-cooled systems are better is that they are compact and energy efficient. But what about maintenance? Here's how we handle this. Let me show you how we service a computer node. First, we disconnect the liquid cooling system through quick disconnect couplings. Next, disconnect the network interfaces and take the node out. That's it. After that, you can do whatever you need. For example, replace the memory chips or handle the power supply unit, the hard disk, and so on. That's everything.
Hidden inside the server racks, there are plates that push running water over the various heat-generating spots on each node. As the water swishes by, it draws the heat out and pushes it on through the rest of the piping and out to the liquid recooling apparatus. The resulting setup is both environmentally friendly and allows for denser arrangements.
The liquid cooling system enables us to place blade servers very close together in the server rack, raising the computer performance to around 180 teraflops per rack. This is a record achievement of ours that no one has been able to emulate so far. Additionally, by using liquid cooling technology, we're able to effectively remove up to 100 kilowatts of heat from each rack.
RCS Group's work is attracting international attention, with leading minds in green supercomputing like Jack Dongara paying a visit at the start of April. He had nothing but praise for the computer that showed the theoretical possibility of a 10 petaflop green machine.
Thanks to the technology that we use, that is, the standardized components and cooling plate, we can ensure that our product is readily available and very convenient in terms of delivery time, pricing, and so on. Besides, by using cooling plates, rather than a network of pipes with many intricate connections, it is much easier to assemble the device and increase its reliability. Since there are fewer connection points, there are fewer potential defects and problems that could arise.
Bearing that in mind, step by step, these noisy and somewhat cluttered old machines are giving way to the new generation of supercomputers and their super efficient cooling systems. With more orderly setups and with none of the blustery ventilation systems, it's hard to compete with the nearly silent and more powerful new kids on the block. But any computer, super or not, is pretty much useless without memory. While the principles behind Moore's Law have worked to gradually expand capabilities over the years, some of the biggest breakthroughs have come in starts and fits. Moving from vacuum tubes to transistors way back when, and looking at the consumer computer market today, another major shift is already underway. One of the biggest shakeups to the old world order in storage has been the decline of hard disk drives. Moving on from the idea of internal moving parts, flash memory drives are taking over much coveted market share. They're already ever present in smartphones and tablets and have muscled their way into ultra-thin laptops. But even before this technology has had its full day in the sun, a potential challenger is on the rise. Researchers at the Moscow Institute of Physics and Technology are pioneering investigations into what's called resistive memory, or memristors for short. Located just north of the capital, the facilities here have been home to some of the greatest scientific minds in the country. No less than 8 former professors have been awarded Nobel Prizes. But back to the topic of memristors. They've been called the holy grail of electronics and combine the best of 2 worlds of storage.
Right now, we are working on what's called a storage class memory device. By combining the high performance of random access memory, this hybrid would also be non-volatile, like a conventional hard drive disk, and be much faster and less expensive than magnetic devices. At the moment, memristor-based resistive memory has the best chance of becoming the next generation storage class memory device.
So here in the lab, their goal is to create a nano-sized switch that can be used for storing info. The hours-long process begins with a simple silicon wafer. On top of that, a layer of metal is added. It could be any number of different ones, but here they've chosen platinum. This forms one electrode of the eventual device. On top of that, their specialized oxide layer is added, practically atom by atom. For this, they've chosen hafnium oxide, doped or imbued with aluminum particles. From there, they add a layer of titanium nitrate as the final slice of bread for their memory sandwich. The end result is a roughly 100 nanometer thick memristor, which functions as an on-off switch and has major advantages over flash. Even though there are no moving mechanical parts, flash memory cells with their floating gates require a more complex arrangement than memristors, which consist of only 3 layers. Instead of the gate memristors, the switch is flipped by changing the resistance of the oxide layer. Whereas flash drives demand up to 10 volts to write and rewrite and roughly 1 to read, memristors need only a fraction of those figures. Furthermore, this futuristic tech can also handle way more rewrites, boosting its effective lifespan. Memristors can be stacked layer upon layer, vastly increasing density and therefore storage capacity. Lastly, resistive memory is faster than flash, offering rewrite speeds of less than 10 nanoseconds. The theoretical basis for memristors has actually been around since the 1970s. It was then identified as the 4th fundamental circuit element after the capacitor, resistor, and inductor. But it took until 2008 before it could be demonstrated in real life by Hewlett-Packard. The wait was so long because of the tiny dimensions of the bits involved. Electron microscopes have to be used to merely investigate what was done in the previous stages. That's needed to analyze things like exactly how oxygen vacancies formed in the hafnium, as well as the size and molecular structure of the oxide particles.
It'll take quite a while before we start implementing this technology in actual devices. But we're working on this right now, and perhaps we're already able to compete with Hewlett-Packard, more so than those who first launched flash memory on the market.
It's thought that memristors could eventually start replacing transistor-based flash drives in the coming years. Given the interest in the topic all around, it shouldn't be too surprising that the researchers here in the Moscow Institute of Physics and Technology aren't even the only ones in their own labs working on memristor prototypes. Home to something called the Common Use Center, other academics regularly stop by to work through the early stages of their own designs. In fact, the unique combination of materials being tried out here is exhibiting some very interesting qualities, which could help create truly realistic artificial intelligence. Further looking into just what memristors could hold for the future are researchers at NTMDT. Here they not only manufacture the equipment necessary for investigating and forming memristors, but they also study designs themselves. The structure of choice here is titanium oxide sandwiched between two layers of platinum. At the moment, they're trying out different etching patterns to see which could revolutionize how we view electronic devices.
It's possible to create analogues of synaptic connections. Brain synapses, that is, the communication elements between neurons, have a certain feature. If you activate them often, their attributes change. Instead of one synapse, a synaptic node develops. So that the old saying that practice makes perfect is definitely true. One has to recycle something numerous times in order to memorize it. Memristors are capable of doing exactly the same thing. They're developing quite rapidly now. Using them, we can make a thinking, cognitive element base that's capable of learning.
Now, there's much still not fully understood about memristors and just what their future holds for ours. But as technology advances, and with all the work that's going on just around the Russian capital, we may not be that far off from machines that think just like we do. And that's an interesting thought indeed. Welcome back to Technology Update. Much of what you've heard and seen today wouldn't be possible without one integral part, the processor. When it comes down to it, its intricate arrangement of circuitry is a foundation around which all other bits and pieces are built. Now, there are a handful of world-famous brands out there, but many of you out there may be intrigued to learn that Russia boasts its very own high-tech center of processor production. Technically part of Moscow, the Zelenograd district has long been the place to go if you're interested in tiny transistor tech. However, this wasn't always possible. While it wasn't a full-fledged closed city during Soviet times, the movements of both people and technology from the area were somewhat restricted. Over the course of the last 2 decades, though, Zelenograd has opened up and blossomed into the home for many of the country's leading high-tech firms. Some 150 companies and organizations, including 2 institutes, have set up shop in the special economic zone designed around the area's knowledge base. There are a good many of great examples we could point to, but one of the standout stars is Micron, which is Russia's leading maker of many things micro, from SIM cards to RFID tags to integrated circuits. In 2012, the company launched a new 90-nanometer production line. With that, Micron is able to produce 36,200mm wafers per year. Certainly something to boast about, but why exactly does Russia need its own mighty microelectronics producer? Well, for that, there seems to be a very good answer.
Microelectronics is an economic as well as a political industry in the world. In some well-known instances, different countries have barred the export of certain microchips. Most recently, the US prevented the export of microchips destined for T platforms, a Russian supercomputer manufacturer.
With that in mind, there are certain industries that really need to have full technological independence. One of the most obvious examples is in air defense systems. It'd be difficult to protect your own skies with your own hardware if nobody were willing to send you the insides. It's the same with satellite navigation. Russia's GLONASS is the only true alternative to GPS with full global coverage achieved in 2011. And while the space race may be as dead as the Cold War, microelectronic hardware can still be considered sensitive information, despite the fact that it's often intended only for peaceful purposes. And a great place to find some of the very latest in homegrown tech is at exhibitions like the New Electronics Show, which took place in Moscow in March of 2013. Hundreds of companies and thousands of specialists flocked to see some of the latest trends in modern microelectronics. There were a number of interesting ideas, some updates of existing tech, others entirely new. One of the more innovative devices we found was offered by Multiclet, a processor maker that has come up with a revolutionary way to get at the age-old problem of how to best organize operations.
Our processor is a unique device which was designed on the basis of a multicellular architecture and had never been implemented in a processor prior to our product. Existing processors that account for a large share of the market worldwide are based on the von Neumann architecture. Our architecture, however, is different.
For most processors out there, parallel action is significantly limited. Operations are rank ordered and information can only be exchanged via the memory, not between control units themselves. With Multiclet, however, things are much more free-flowing, and crucially, information can be exchanged between operations directly without having to go through the memory. And in Multiclet's quest to make its mark in the marketplace for processors, they've teamed up with one of Russia's most in vogue innovation funds, Skolkovo. As a member of the startup from the organization's space cluster now, Multiclet has found a willing co-conspirator in a company called Sputniks. Also a Skolkovo resident, Sputniks is in the business of developing the next generation of satellite technology. They believe in a kind of Lego type of satellite, meaning that everything should be standardized and easy to build with a proper set of pieces. Even in their simple office space, they've got just about everything they need. At their testing stand, they check to see just how well the sensors interact with the software to make adjustments automatically. But the hardware that eventually gets put on board their miniature Earth orbiters will have to deal with conditions slightly more testing than the air-conditioned rooms here.
We cannot use ordinary processors like Intel and AMD in space and other complicated technical systems. There is no earthly atmosphere there, which would protect them from solar radiation, and the temperature range is quite broad. Therefore, special solutions are required so that the machine could operate and function there for some time. This processor is designed in such a way as to enable the parallel processes inside it to happen on a multitude of cells. And if something happens to one of those cells, it doesn't fail, but just slightly slows down. As a result, it's hard to disrupt its work.
Now, for Sputniks' current models under development, the latest Multiclet chip wasn't ready for action. It's reportedly undergoing the final checks to ensure that it can handle any climactic conditions thrown at it, including those beyond the temperate environs of Earth's atmosphere. But with the help of Multiclet's interesting, if not innovative design, Sputniks should be at the front of the pack as space operations shift from giant state organizations to smaller, more nimble teams. For some users, though, it's all about trust rather than pure performance. With that in mind, a microelectronics brand name that stretches back half a century has come out with a new chip that removes the worry about hidden holes in security. With its roots in the institute that built the top Soviet supercomputers, the Moscow Center of Spark Technologies has become one of Russia's top microchip makers. And their most recent offering is the Elbrus IIS+. It comes with a clock speed of 500 MHz, 2 cores, and boasts processing power of 16 gigaflops. Unlike many RISC-based processors out there, Elbrus IIS+ relies on a compiler to execute parallel operations more effectively. With that in hand, they've branched out and have bigger targets in sight.
The Monocube board is our attempt to make quite a cheap, affordable computer based on our latest developments, that is, the Elbrus IIS+ and KPI Southbridge.
The board forms the basis for a brand new computer, the KM4 Elbrus. Produced by one of Russia's leading computer hardware makers, Craftway, the first batch of them has already rolled off the production lines. They're equipped with a touchscreen and can run either Linux or Windows. While it may offer performance on par with world leaders, many who turn to Elbrus do so for another, no less important reason.
At the moment, we see that our main clients are primarily state institutions and organizations that are concerned about security issues. Since we developed the system from top to bottom, meaning the motherboard, compiler, BIOS, and libraries, we have what we'd call credibility. We can guarantee that our product doesn't have undeclared capabilities, So those interested in security would find our product attractive.
At every step along the way, these engineers seem to have security in mind. Whether it be choosing a tried and true company like Micron to handle the actual production, or writing in a special secure mode which prevents a potentially malicious program from gaining direct access to the memory. The Moscow Center of Spark Technologies ensures that safety doesn't take a backseat to outright processing power. However, in the world of microelectronics, it's certainly not all doom and gloom. With transistor sizes continuing to shrink, this high-tech industry is confidently striding into the future. Well, that'll do it for this edition of Technology Update, as well as for my time as your humble host. I'll be bidding you adieu, but catch the latest next time with the rest of the team. And until then, enjoy the ride.